You see an explosion in the sky, a bright flash, a cloud of smoke, and nothing hit the ground. Your first thought is probably that something went wrong. A missile misfired. A system failed. It missed. But in most cases, you see in news footage that explosion in the air is not a failure. It is exactly what was supposed to happen. To understand why, let us start with a simple scenario. Imagine one country detects that another has launched a missile headed toward it. The radar sees it coming. The military has minutes to respond. So they launch their own missile, an interceptor, designed to stop the incoming threat before it reaches its target. Now you have two missiles in the air, traveling at high speed, on paths that will bring them close to each other. The question is, how do you make them collide, or get close enough that one destroys the other? Here's the problem. Hitting a moving target is extremely difficult. Both missiles are traveling fast, and both are moving through three-dimensional space. Even a tiny error in timing or direction means a miss. If the interceptor has to physically touch the incoming missile to work, and it misses by even a small distance, nothing happens. The incoming missile keeps going, so engineers faced a choice. Either make the interceptor incredibly precise, which is very hard, or change what hitting the target means. They chose the second option. Instead of requiring a direct hit, they designed the interceptor to work if it simply gets close enough. That is where the proximity fuse comes in. A proximity fuse is a sensor built into the nose of the interceptor. Its only job is to detect when the missile is close enough to its target and to trigger detonation at exactly that moment. The most common type works using radio waves. The fuse continuously emits a low power signal outward. As the interceptor approaches the incoming missile, that signal reflects back. When the reflection reaches a certain strength, meaning the target is close enough, it fires. Modern versions use laser pulses instead. The fuse sends out brief bursts of light and measures how long they take to return. Faster, more precise, and harder to confuse with background signals. In both cases, the logic is the same. Measure distance continuously and detonate when that distance drops below a threshold. Now you might ask, how does an explosion that does not directly hit the target actually destroy it? This is the key to understanding the whole thing. When a warhead explodes, two things happen at the same time. First, the metal casing breaks apart into fragments that travel outward at very high speed. Second, the explosion creates a pressure wave, a sudden violent push of air that spreads out in all directions. Both of these, the fragments and the pressure wave, are dangerous within a certain radius. Depending on the warhead, that radius can extend tens of meters in every direction. Think of it like this. Imagine throwing a firecracker near a model airplane. The firecracker does not have to hit the airplane to damage it. If it explodes close enough, the blast and the fragments do the job. A missile warhead works on the same principle, just with much more power. So what happens to the incoming missile after the interceptor explodes near it? The incoming missile does not simply disappear. It gets hit by fragments and by the pressure wave. Depending on how close the explosion was, it might be completely destroyed, breaking apart in the air with pieces falling to the ground. Or it might be damaged enough to lose control and tumble out of the sky. Either way, it no longer reaches where it was going. If the incoming missile carried its own warhead, the fragments sometimes detonated in the air, which is why you occasionally see a second, larger explosion shortly after the first. That is not a malfunction. That is the interceptor doing exactly what it was supposed to do. Not every interception works this way, though. There is a second type worth understanding, because it produces a very different visual. Some modern interceptors carry no explosive warhead at all. They are designed to physically collide with the incoming missile. At the speeds involved, often several kilometers per second, the kinetic energy released on impact is enormous. The collision itself is the destructive event. These are called hit-to-kill interceptors. When they work, you still see a flash and debris, but it comes from the impact, not from a warhead detonating. Hit-to-kill is preferred when the target carries a payload that must be physically destroyed, and a near-miss explosion would not be enough. Proximity fuse warheads are used when getting close is sufficient to neutralize the threat. There is one more thing worth understanding, because it explains something else you might notice in footage. The interceptor does not fly straight at where the incoming missile is right now. It flies toward where the incoming missile will be. This is called predictive guidance. The interceptor's computer and the radar systems on the ground are constantly calculating the target's speed, direction, and trajectory. The interceptor is steered toward the predicted meeting point, the location in space where both missiles will arrive at the same moment. This is why interceptions sometimes look strange from the ground. The interceptor appears to fly at an odd angle or slightly past the target. It is not confused. It is flying to a point that does not yet exist, based on where the math says the target will be. When both missiles arrive at that point, the proximity fuse detects the target and detonation occurs. So when you watch footage of a missile exploding in the sky, here's what you are actually seeing. A radar detected an incoming missile. A defending system launched an interceptor. The interceptor was guided, not toward where the threat was, but toward where it was going to be. The two missiles converged. A sensor in the interceptor's nose detected the target within range. The warhead detonated. Fragments and a pressure wave spread outward. The incoming missile was hit, destroyed, and fell from the sky. The entire sequence, from launch to explosion, can take less than a minute. The visible event, the flash, the smoke, the debris, lasts only a few seconds. The explosion in the air is not a sign that something failed. It is the last step in a precise engineered sequence, most of which happened invisibly, at speeds no human observer could follow. What looks like chaos from the ground is, in engineering terms, a solved problem.